Welcome to another tutorial of ProfLearn YouTube channel. In this particular video, we're going to discuss some of the concepts that you have to prepare for your coming exam of May-June 2025. In this particular video, we're going to go through main areas, how you are supposed to approach them as far as IGCSE Edexcel Paper 1 is concerned. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. Let's kick in and look at the first question that ProfLearn prepared. And we are told that here the graph shows thinking distance and breaking distance and how it varies with time of a speed of. Now in this case, we are told which of these does not affect the thinking distance. You need to know that thinking distance is the distance a car covers while the driver is thinking exactly what to do, and the braking distance is the distance covered by the object or by the car from when the driver applies the brake until when the car comes to a complete rest. And also you need to understand in this case what we mean by reaction time, and you need to understand that the reaction time is the time taken for the driver to take action on a given hazard. So in part A, we're supposed to state which of these does not affect thinking distance, and we're going to realize that this is the condition of the road. Thinking distance is not affected by the condition of the road, because if a person has consumed alcohol, this is going to affect his ability to make decisions, and if the car is moving very fast, it's going to cover a larger thinking distance, and the tiredness also is gonna affect that. Which of these will increase the braking distance of a car? We can talk of the sliding of an icy road. If a car slides, it's going to have a larger braking distance. Determine the stopping distance of the car when the speed of the car is 20 meters per second. So which means that we are going to check, we have the speed here 20 meters per second. We are going to move up and check what is the distance covered. So you move across to check the distance, and here you move, you check the distance here, and you can be able to identify the distance here is 26.5. And then if we can be able to add the two, we can be able to get the stopping distance. And then the next question, we were supposed to say the formula linking average speed, distance, and time taken, and we're going to say that average speed is equals to the distance moved divided by the total time taken. Next question is to determine the reaction time of the driver of the car. In order to work out this question, you are going to realize that we need to check. Now, before answering that question, I want you to identify and understand that this question can be asked whereby you are given a velocity time graph, and this is going to give us the constant speed. The constant speed or constant velocity is when the person is thinking, and if you are given that, this point here will give you the reaction time, and this region area under the graph, this region is going to give you the thinking distance, and this part here is going to give you the braking distance, but this one will give you the thinking distance. So meaning if you are given a question like this, you need to understand that you can be able to get the reaction time where the flat graph ends, and you can be able to work out area under the graph from a velocity time graph to get the distance moved. Now in this question whereby we are supposed to work out the reaction time, I want you to look at this graph that we're having, the thinking graph. Thinking distance graph is this one, right? So if the speed is 30, the thinking distance you can see here is 15. So how can we be able to work out the reaction time? So we can be able to say that when the speed is 30, the thinking distance is 15. So we can be able to work it out and say, remember, speed equals to distance over time. And basically we are just using this. Then we can be able to work out the time, and this would be 30 is equals to 15 divided by the reaction time, which means our reaction time T is going to be 15 divided by 30, which becomes 0.50 seconds. So our correct answer for that case is 0.50 seconds. Calculate the mean braking acceleration of the car as it brakes to a stop from the initial speed of 30 meters. From the initial speed of 30 meters per second. So let us check from initial to brake. Right, we have the measurement there. We're going to use the equations of motion. The distance is what? The distance you can see here is 53 meters. And then the initial velocity will be 30 meters per second. For it to brake, we're going to use the equations of motion here and say v squared equals to u squared plus 2as, and in this case, you know, it's decelerating, and then final velocity will be 0, so it will be 0 is equals to initial was 30 squared plus 2 times the distance, acceleration times the distance, which is 53, and this is going to be a is equal, so I want to make a the subject, it will be 900 negative divided by 2 times 53. If you work it out, you are going to get the acceleration being negative 8.5 meters per second square, meaning the object decelerated at a rate of 8.5 meters per second. Now, question 2, we are told that the teacher uses this circuit to investigate how current in a circuit changes with the temperature of a room. We have a thermistor here, and remember, a thermistor is a type of resistor whose resistance depends on the temperature of the surrounding. If you increase temperature, resistance decreases, meaning more current can be able to flow. We have a fixed resistor of 140 ohms, and then which is connected in parallel with a voltmeter. Remember, a voltmeter is connected this way. Now, we are supposed to calculate the voltage across a thermistor, and something you need to understand that the voltage across the thermistor plus the voltage across the fixed ohm resistor, which is 140 ohm resistor, should give us the total voltage, which is 1.5. So meaning that in order to work out the voltage drop across the thermistor, it will be 1.5. Then we shall subtract the 0.91, which is the voltage across the 140 ohm resistor. So we are going to say this is going to be 1.5 minus 0.91, and that is going to translate to 0.59 as the voltage across the thermistor. Next question that we need also to know how to state is the formula of voltage, current, and resistance, the formula that connects voltage, current, and resistance, which is basically Ohm's law. And this is now going to be used to determine the resistance of the thermistor. Of course, we know the resistance is given by voltage divided by current. Voltage that we had gotten here was 0.59. but the current that is passing through a series circuit is the same throughout, but you have to convert the milliamperes to amperes by dividing by 1,000, because the value that was given there was 6.2 milliamperes, so we had to divide that by 1,000 so that we convert it to amperes. So working it out, our final answer becomes 95 ohms. We are supposed to describe the relationship between temperature and resistance. In this case, you can see is a curve that is not a straight line. So if it's not a straight line, it means it's in these two quantities have a nonlinear relationship. If you get a straight line and you are asked a question like this, you are supposed to say they have a linear relationship. But in this case, they are nonlinear, and you can see as temperature increases, resistance decreases. So they are inversely proportional. So you can be able to say the resistance of the thermistor decreases with increase of temperature of the surrounding. So we can say that they have a nonlinear relationship in this case. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. Explain how the reading of the thermistor or the voltmeter changes when the temperature of the room decreases. Remember, when temperature of the room decreases, resistance of the thermistor is going to increase. So therefore, the overall resistance of the circuit will increase, which means less current is going to flow. Thus, the reading of the voltmeter also is going to be less. So we are going to say that as we have this voltmeter, so as the resistance of this thermistor increases due to the decrease in temperature, so as the resistance of the thermistor decreases, it let me just let me take some water. All right, so when temperature of the room decreases, it means resistance of the thermistor is going to increase. When resistance increases, the voltmeter reading is going to do what? To decrease. And I've given a reason as to why that is the case. We're going to say as temperature of the room decreases, resistance of the thermistor increases. And this is going to decrease, or this is going to decrease the amount of current. So the current in the circuit will be less. So the voltmeter reading will decrease, will be smaller. Right, that is exactly what you ought to have mentioned. That you need also to understand regarding the light dependent resistance. In your exam, you may be asked about a thermistor, you may be asked about a fixed resistor, or you may be asked about light dependent resistor. Moving to the next question of electromagnetic spectrum. In electromagnetic waves, you need to understand different uses of electromagnetic spectrum. You need to understand different properties of electromagnetic waves, and also you need to understand the different uses of each. You need to understand their hazards, their effects in the how they can affect human life. You need also to understand the wave equation of the and how to use it in the electromagnetic spectrum. So in this case, we are supposed to draw a straight line from each electromagnetic waves to its correct use. Remember, infrared are used for cooking, radio waves are used for communication. Ultraviolet, they can be used for production of light in fluorescent tubes. We can talk of X-rays, which are used for security check, also where we can be able to check flaws and cracks in metals. X-rays can also be used in X-ray machines to detect broken bones. Visible light can be used to see or record videos or take photos and pictures. Now, we can be able to draw a straight line from X-rays to detect bonds. We can draw from visible light for human vision. Infrared for cooking because they can heat up objects. Remember also microwaves used for cooking. Yes. Then we can talk of ultraviolet detecting forged banknotes and using fluorescent lamps. Yeah, banknotes in a sense that if the UV rays are directed to those security marks, they can glow and they can be able to produce kind of visible light that can be able to see those marks. All right, so we need to move to the next question and check whether what was being tested. Yeah, I mentioned something to do the hazards. Human exposure, excessive human exposure to infrared can cause skin burns. Yeah, so this can cause skin burns. You need to understand for gamma rays, X-rays can cause cancer, ultraviolet can cause skin cancer. Radio waves, really the effect is not really known, but you should not be exposed so much on it. We can talk also about microwaves. Microwaves can cause internal heating of body tissues. So it depends on which part of the electromagnetic spectrum we're going to ask in the coming exam. We're supposed to know also the precautions. Of course, you are not supposed to expose yourself to these radiations so much because of this effect they can cause. Then you are supposed to say that a precaution that will reduce a person's risk to exposure of UV. We can talk of applying of sunscreens so that you are not really affected by the UV rays. Moving to the next question here, just looking at a scenario whereby there is a child who's on a zip line ride, and you see as a person rides on a zip line ride, there are different forces involved. Yeah, there is tension that is acting upward because of the string that is holding the person from falling. Then the weight of the person will be acting downward, and as the person moves along the zip line, you realize that there will be air resistance that will be acting up against the person as he slides along. Now, the force and velocity are examples of vector quantities. In your exam, you may be asked to state what it means by vector quantity, and this is exactly what you need to say. This is a quantity that can be described by both size, or magnitude, and direction. So vector quantities, they have both size, or magnitude, and direction. But if we are talking about scalar quantities, they are quantities which can be only described by size. They don't have directions. And you need also to understand the differences, the different examples involving vector quantities and scalar quantities. And to mention the few, vector quantities include velocity, include force, different types of forces, weight. You see it has size and direction. Momentum is another example of a vector quantity. Impulse is also acceleration. We can talk of acceleration, yes. But if we are talking about scalar quantities, quantities like distance, quantities like speed, quantities like density, quantities like pressure. Yeah. But if we are talking of displacement, displacement is vector, but distance is what? Scalar, because displacement has both size and what? Direction. So as you are going to do these exams, you need to know how to define those terms, vector and scalar, and giving the examples. Make sure you don't blame yourselves when you are going to get similar questions in your exams, and then you start wondering whether you are really prepared for that exam or not. ProfLearn has just hinted you that those are the areas that you should prepare and look at them as if your life depends on them. Draw a labeled diagram to show the labeled arrows on the diagram to show two other forces that act on the child. Of course, we are going to identify the weight that is acting downwards, and then we are going to, yes, this is the weight that's acting downward, and then we have the air resistance, weight, this direction, we have air resistance, or drag that is acting in that direction. As you can see, this person is enjoying swinging on a zip line ride. If you are finding value from this particular video, consider subscribing so that anytime we are going to upload another tutorial, you'll be notified. So another aspect of the concept another concept that you need to understand, need to prepare on, is the concept on magnetism. Now let's change the gear. We need to understand talk about magnetism. Remember that the magnets, they have two poles. We have a north pole and a south pole. And if you have unlike poles, a north and a south, or a south and north, they are going to attract each other. So unlike poles attract, like poles repel. So we need also to understand that we have magnetic fields around the poles of a magnet, and you need to remember that the magnetic fields have properties, that is directional properties. The fields of the magnet point from the north towards the south. We can also see this when the poles are going to be switched. There is attraction when you have unlike poles, but if you are going to switch these poles, there is going to be repulsion. We are going to have repulsion. If you are having same poles, the magnets are going to pull apart, and that's what we call repulsion. So if you have a north pole like this, they are going to repel. But if you switch and have the south and south also, they are going to repel. If you are having a north and a south, there is attraction. They are going to greet each other. Look at that, the way they are going, right? Very interesting. Let's move further and look at more concept on magnetism. We have permanent magnets. You can see we have materials which are attracted to that magnets, and those materials which are attracted by magnets are called magnetic materials. And then we can see a tractor here trying to lift materials, and then that is an electromagnet, yeah, which is a temporary magnet. And for you to create a temporary magnet, you are going to use soft magnetic materials like iron. But if you are going to create a permanent magnet, you are going to use hard magnetic materials such as steel, so that they can be able to retain their magnetism for long. We need to understand that a magnet has got a north pole and a south pole, and around a magnet we have magnetic fields, and these magnetic fields are pointing from the north heading to the south. Some of the properties that you need to remember regarding magnets is that some of the properties of magnetic field that you need to remember is the directional property. They point from the north to the south. And also you need to understand that where the magnetic fields are straight, it means, and very close, it means that magnet is strong at that given point. You need also to understand that magnetic field should not cross each other. That would be very wrong. So you can be able to identify such mistakes when you are given a question on magnetism. You need also to be able to identify uniform magnetic field, but in this case we are supposed to identify the correct one, and you can see this is wrong because it's pointing from south to north. Check this one, seems like right, huh? Let's check this one is wrong because it's south to north. Yeah, that's a mistake. And is there a mistake? Yes, yeah. So directional property was identified in A, C, and D, so the correct one is B. Then another concept that you need to understand is the law of magnetism, that unlike poles attract and like poles repel. And you can see here we are having a scenario whereby a magnet is able to attract. Which of these describe what happened to the two magnetic fields? And you can see now we are having attraction because we are going to have uniform magnetic fields. You may be told to draw uniform magnetic fields. For you to have a uniform magnetic field, you must have two poles, two opposite poles of a bar magnet opposite to each other. So you can see this is a uniform magnetic field because they are equally spaced and they are very straight between the opposite poles of a bar magnet. Which of these arrangement gives a uniform magnetic field? You can see this is non-uniform magnetic field here, non-uniform magnetic fields here, non-uniform magnetic field. There is repulsion there. Basically here, that's where we have uniform magnetic fields and they are pointing from the north to the south. Here we are having non-uniform magnetic fields in this case. State the name of the material that will be suitable for a permanent magnet. This is a steel metal because steel metal is a hard magnetic material. If it's a hard magnetic materials are materials which are difficult to magnetize, but once magnetized, they retain the magnetism for a period of time. But we need also to identify soft magnetic materials. Soft magnetic materials are materials which are easily magnetized, but they can lose the magnetism quite fast. So these are materials which are used to make temporary magnets. Such materials are like iron, which are used to make temporary magnets. So as far as this concept is concerned, you need to understand the difference between hard magnetic materials, soft magnetic materials, example for each, and then their uses. Another area that is very, very ripe for your exams, an area that will be smelling in your exams, is the area of how to investigate and determine the shape of magnetic fields around a bar magnet. And in this case, we're going to say we're going to use iron filings, and then we're going to use a piece of paper whereby we're going to sprinkle some iron filings on that piece of paper and then tap that piece of paper. So in this case, we're going to say place a bar magnet on a flat surface and then sprinkle and put a piece of paper on top of the bar magnet. Then once you've done that, you are going to sprinkle some iron filings on that. So I'm going to sprinkle some iron filings. Let me sprinkle some iron filings and then tap that piece of paper so that the iron filings can be able to and then I'm going to have a particular pattern. The pattern, the arrangement I will have will represent the magnetic field patterns. And then to determine the direction of magnetic fields, I'm going to use plotting compass. To determine the direction of the fields, I'll use plotting compass. Plotting compass. All right, the next topic that you need to prepare for your coming exams is the topic of radioactivity. You need to understand how to determine half-life. You need, from a graph, you need to know how to define half-life as a term itself. And also you need to understand when a particle gives out or undergo radioactivity by emitting alpha particles or beta particles, how does it transform the nucleus? You need also to know the nuclear equations, which we are going also to discuss in further tutorials. Now, we are going to look at this question whereby we are told that a scientist wants to determine the half-life of a radioactive isotope. You need also to know how to define isotope. Isotopes are atoms of the same elements which have the same mass number but different which have same atomic number but different mass numbers. So you need to know how to define this kind of terms. State how the scientist will correct the count rate of the background radiation. We are told that a scientist measures the count rate from a radioactive isotopes. How does the scientist correct the count rate for the background radiation? Now, before we answer this question, I need to bring it to our attention that background radiations, these are radiations that are always present in the environment. And background radiations can be as a result of the following. Number one, the radon gas in the environment. We can also have radioactive materials or sources of background radiation include radon gas in the environment. We can also talk of cosmic radiations from space. We can talk of rocks and buildings because they have some traces of radioactive materials. Then we're supposed to state how the scientists should correct the count. Remember, once you have taken a reading using a GM tube to measure the count rate include the count rate of the radioactive substance as well as the background count, which is always present in the environment. So in order to correct this, you need to remove the radioactive substance away from the detector and then record the reading it's showing. And the reading it shows absence of radioisotope is called the background count. So you are going to subtract it from the count rate that you did what? You obtained. So we are going to say in this question how the science should do that. Then we should take a reading without a radioactive substance near the detector and then subtract it from the count rate that was obtained from the radioisotopes. In that way, we are going to correct the count reading. Now let's see which question was asked here. After this, we have a graph and we are supposed to explain what's meant by half-life. These are some of the terms I've mentioned that you must know how to define. Half-life is defined as the time taken for the activity of a radioactive substance to decrease by a half. This is the time taken for the activity of a radioactive substance to decrease by half. Use the graph to determine half-life. How do we do that? We are going to identify the initial when time is 0. Take that value, divide by 2, go on the activity axis, and then identify where we have 25, draw a line across, and then where it meets the graph, join downward and read the value that you have at this given point. And that's going to translate to 2.6 kilobecquerels. Now we move to astrophysics, and remember astrophysics is a concept where you learn about astronomy and then later on you learn about cosmology, which is the origin of the universe. Now under astronomy, we are going to talk about stars, evolution of stars, different celestial bodies we have in space. Then you need to understand which of these represent a collection of billion of galaxies. Collection of billion of galaxies is basically the universe. Milky Way is our galaxy where the sun is part of, and then the solar system comprises of a star and planets, and the nebula is the dust and gas particles which is used to in the formation of stars. Now we shall discuss that in detail in the next video. So if you have not subscribed, please consider subscribing so that anytime I'm going to upload that video, you'll be notified. Now, which of these is the correct unit for gravitational field strength? That is Newton per kilogram, which is correct. So this one we said is collection of billion of galaxy stars is called a galaxy. Yeah, solar system we said comprises of star and planets. We have Milky Way is our galaxy where the sun is part of, and then the nebula is used to formation of these are just interstellar dust particles in space, which is used to in the formation of stars. Right. And then we're supposed to describe the differences between, okay, all right, I think this one I was almost forgetting about it. The moon has a less mass than the earth, that's why it has a less gravitational strength. I remember gravitational strength depends on the distance, the radius, or the distance of the bodies. If the distance is so big, then it means that the gravitational field strength is going to be less. And also the masses, the size of the masses determine the gravitational field strength. So if an object is massive, it has a large mass, it's going to have a larger gravitational field strength. Right. We're supposed to describe the differences between orbit of the moon and orbit of the comet. We need to agree that let us try to draw the orbit of a comet here, and the comet goes around the orbit, and you see the sun is gravitated to one of the ends toward the edge of the orbit, and that is not the case in orbit of the moon. So you realize that when the comet is farthest, like this point here, it moves very slow because the force of gravity is less. But when it's very near to the sun, like this one, it moves very fast. And then it moves fast because at that point there's a stronger gravitational pull at that point. Now let us draw the orbit of the moon. Remember the moon orbit around the earth, and then we can be able to base our differences based on the diagram that you have to see here. Remember, you may include your answer a diagram to support your answer, and in that way you can be able to easily describe what you are seeing there. So we can say that the orbit of the moon is circular, while the orbit of the comet is very elliptical. It's very elliptical or elongated. Orbit of the moon is around the earth or the planet, while the orbit of a comet is around a star, is around a star, is around a star, is around a star. Now, I think we are done with that, and the force that keeps this object to move around is the gravitational force. Something I need to mention before moving out of this page is that you need to know how to find the orbital speed, the speed at which this object moves around the bodies. And the orbital speed is given by 2 pi r, where r is the radius and t is the periodic time it takes to orbit around. Right. Then we can now move out of this area. We go to Mr. Ali. Mr. Ali is having a camel, is walking with his camel, is having a good time. Mr. Ali is walking on a sun in a desert. As Mr. Ali is walking, his feet is sinking into the ground. And Mr. Ali, as he's walking, is feeling like the feet is going into the sand. Why? Because it's exerting pressure. And remember, pressure is force exerted divided by the area in contact. All right. Now, between Mr. Ali and Mr. Camel, who's going to exert a larger pressure on the ground? Now, you need to ask yourself factors that affect pressure in solid, that's force and the area in contact. You use a sharp knife because it exerts a greater pressure due to having a very small surface, so it can cut deeper when you apply small force. Needles are sharp to increase pressure. Now, if you want to reduce pressure, you need to increase the area in contact. So tractors and heavy road carriers in the road, they usually have many ways to increase the area in contact, and that reduces pressure. Let's look at this question without much ado. Describe the method you will use to find the pressure of the person. Now we want to describe the method we can use to find the pressure Mr. Ali exerts on the ground. Remember, we need to know what is the force Ali exerted. The force Ali is going to exert on the floor or on the sand is going to be equivalent to his weight. But we see there is area in contact and there is the weight that is acting downward. So the weight is going to be the force, and the size of the foot of Mr. Ali is going to be the area in contact. So in the process of working this question out, you need to work out the area of the foot. And what is the procedure of finding the area of the foot? We can be able to outline the foot of Mr. Ali. So we need to measure the area of the foot of Mr. Ali. So area of the foot, by drawing an outline of Mr. Ali's foot. Sorry, we need to draw the outline of the foot of Mr. Ali on a graph paper, so that we can be able to use square counting technique in order to find the area of that. Then also measure the mass of this person using a beam balance. We get the mass. Once we have the mass, we can be able to calculate the area using the formula weight. We can be able to calculate the weight of the person using the formula weight equals to mass times gravity. Then remember, the weight is going to be the force this person is going to exert. Then pressure will be calculated by the formula force exerted. Pressure is going to be equal to the force exerted divided by the area in contact. And that's exactly what we are going to do here. The total area of the camel's feet with the ground is 1300 centimeters square, and the mass of the camel is 660 kgs. We are supposed to calculate the pressure this camel exerts on the ground. We know that pressure is equal to force over area, but before we do that, we need to work out the weight of the camel, which will mean that the weight of the camel is going to be 6,600 newtons. And then once we have the weight of the camel, we can be able to work out pressure comfortably by saying force over area, and the force is the weight exerted, the weight of the camel divided by the area of the feet of the camel. Working it out, we're going to get our answer equivalent to 5.1 Newton per centimeter square, and then we transfer this answer here to make the examiner happy. Right, so we need to look at the next question that we are having here. We are going to move into the atomic structure of an atom. The number of protons in the nucleus, and that is going to represent the part C. Which statement describes the term mass number of a nucleus is the sum of protons and neutrons in a nucleus? So that is going to be our value D. You need to state also which statement describes an isotope, and we're going to say these are atoms of the same element with same atomic number but different mass numbers. And remember, the difference in the mass numbers is due to the difference in the number of neutrons. And for that case, we are going to say the answer for that and that is D. All right, moving to part D, we are told that an atom contains 8 protons and 8 neutrons and 8 electrons. You need to remember that in a neutral atom, the number of protons and the number of electrons are equal. So we are asked which of these will result in a negatively charged ion of the same element. If you are introducing an electron to an atom, it becomes negatively charged. If you remove an electron, it means you are going to have less electrons, which means that the ion now become positively charged. So to have a negatively charged ion, we are going to add an electron. Remember, protons are not transferable. They are bound in the nucleus. So the correct answer for this is actually A. Moving to part E, it's not possible to predict exactly when a radioactive nucleus will decay. Then we're going to say that is random. So the term that explains that observation is that it's random. The radioactivity happen randomly. You cannot be able to predict which one is going to undergo radioactive decay. Which of this is the correct unit of measuring the activity of a radioactive active sample? That is becquerel, and that is A. Of course, coulomb is the unit for charge, joule is the unit for energy or work done, and watt is the energy for power. Energy for power. All right, we need to move further and get to see what are the other concepts that you need to prepare as maybe. Let's look at pressure. State the formula linking pressure difference, height, density, and gravitational field strength. And this is pressure in fluids. Pressure in liquids is equally height times density times gravitational field strength. So this is the formula you use. But if it's pressure in solid, is force over area. You need to remember that. The pressure difference between the surface of the water and the water at the bottom of the bottle is 2300 pascals. Calculate the depth of water in the bottle and give your answer in centimeters. Now, we are told the density of water is 1000 kilogram per meter cubic. Then we're going to apply that formula that we said, H rho G, that pressure equals to height times density times gravity. And then we're going to substituting the formula, but we are finding the height, isn't it? Times 10, gravity is 10. Then if we make h the subject of the formula, which I divide by 10,000, if we work it out, we are going to get our answer equivalent to 0.23 meters. But our question expected us to work out our answer in meters, in centimeters, so we have to convert this to meters by multiplying to 100, and our final answer becomes 23 centimeters. Well, we need also to understand that since C and B are at the same level, the water is going to gush out of or C at the same speed because pressure act in all directions. Pressure act equally in all directions. So that is how it will flow. But for air, water will flow that way because at air we have a shorter height. So pressure at air is less. So water is going to gush out at a lesser speed. So it will not cover such a large distance across. So you're supposed to explain the part of water leaving bottle air. We're going to say pressure at air is lower. So the force at which water is going to get out is going to be less, which means that water will leave at a lower speed. Water will leave at a lower speed, hence will cover a short distance, horizontal distance in that case. But at B, it's much because pressure in liquid depends on density, height, and gravity. You can see there's a hole at the top of the cup. What is the purpose of that hole? That the opposite side of the bottle explain the shape of the path of water leaving the bottom of C. Remember we had said that C is actually at the same level with B, so which means that pressure is the same. Pressure is the same, so water is going to gush out and will have the same shape as that of B because pressure is the same and the speed of water will be the same as that of B. So it means that we are using the concept of fluid. Pressure in fluids is equally distributed. Pressure in liquids or fluids act equally in all directions. Suggest why there is a hole in the cup of the bottle. That one I've already opined and mentioned that the purpose of that hole is to equalize pressure inside and outside. Moving to question number 11, and this is the mastery that I mentioned that you are going to do. I want you to just test yourself, answer all these questions, and then check what score will you get. You'll score X out of what? This question is out of 8 marks. So how much will you score? All right. Question number 11A. Which of these is the unit of activity? Write your answer. Part B. Which of these is the correct description of the term half-life? What's your answer? Part C. A teacher demonstrates how the activity of a radioactive sample changes with time. The box gives the names of different pieces of equipment. We have a ruler, stopwatch, balance, Newton meter, protractor, GM tube, voltmeter, and ammeter. Complete the sentence using the words in the box. The teacher measures time with a dash. The teacher measures the count rate with a dash and a counter. The next question is to state the half-life. Anomalous point. You draw a line around anomalous point, anomalous result. Which one is the anomalous result in this? Use the graph to determine half-life. Then we are supposed to give similarity and differences between orbit of a planet, and orbit of a moon. Similarity and differences, you're going to state that. All right. All these are the questions that you are going to answer. And for the question number 12, it will be X out of 7. Now let's go back and get to write the answers that you are supposed to write for number 11. The correct answer here is A, becquerel, 1 mark. The correct answer for half-life is time taken for the activity to decay. Yeah, time taken. Time taken for the activity of a substance to halve. That is A, 1 mark. Next question. The best choice here is a stopwatch and a GM tube. A stopwatch to measure time, and to measure the count rate, it will be a GM tube. You'll earn here 1 mark also. A ruler measures distance, balance can measure mass, Newton meter measures force, protractor measures angle, voltmeter measures voltage, ammeter measures current. Moving to the next question, this one attracted 1 mark. Did you score that? Anomalous point, you can see the point that is above the line, very far from the rest, that is the unusual value. And whenever you are identifying, maybe if you are supposed to use to find the mean and there is an anomalous point, you can ignore that point. All right, next question. You are supposed to find the half-life. You'll identify the activity when time is 0, that is 50, divided by 225. Then you are going to read down here, and that's going to be 15. Did you get that? 2 marks. Give the reason why the teacher should not expect the data point to lie exactly on the curve of best fit, because radioactivity or activity is random. So somehow we are going to have values which cannot lie along the curve of best fit. The decay is random. So something that you need to understand is that planets, they orbit around a star, and when you look at their orbit, the orbit is elliptical, which means that they are having an orbit that is elliptical and they are orbiting around a star. But the orbit of a comet, is very, very elliptical and elongated. As you can see, as this comet is approaching, it's going to go around the sun, and the sun is towards one edge of that particular orbit. We also have this other comet that is coming from down here, and it's going to go around like that. It goes around the sun. So both the orbit of a comet and orbit of a planet, both of them, they orbit around the star, and that is the similarity. But the difference is going to be in the shape. You see, the orbit of a comet is very elliptical, very elongated. And while the orbit of a planet is elliptical, but not really very much stretched as that of a comet. So this is the moon. So similarity, both of them, they have almost a circular orbit. Both of them have almost a circular orbit. Somehow the orbit is almost circular, but the difference is a planet orbits the star while the moon orbits a planet. That's the difference. And that will attract 2 points. Next question, you'll be seeing question whereby you are supposed to state why is a line graph used, why is a bar chart used. That one, it depends on the type of data provided, and when you are looking at this, we're going to say the reason as why a bar chart is the best um, model of view of representing planets and their gravitational field strength, because we are dealing with discrete data. Planets are discrete data. We are not having continuous data here. If it's a continuous data, you can use a line graph. So the reason is because the data is discrete, non-continuous. Use the information from the bar chart to determine the ratio of the orbital speed, the ratio of the orbital speed of Jupiter to that of Uranus. So we are going to go on the graph there so that we can be able to identify and check the orbital speed for Uranus is this mark here, this one here, and that is approximately 6.75, and for Jupiter that is approximately 13. So if we are finding the ratio, basically we're going to divide them, and that's going to translate to 1.9. Suggests the reason why Earth has the largest orbital speed, because this is the closest planet to the star, or to the sun, is the closest planet to the sun, right? Moving to the next question, now we can be able to change the gear and get to see what is the next question talking about. Out of 15 in this mastery, can you comment in the description how many marks did you score in the mastery in this video? I can't wait to read your comment on how you scored in this mastery. Now let's move to number 13. The diagram shows a balloon with a mass attached, held at rest below the surface of a deep pool of water. The balloon and the mass are released. The graph shows the velocity time graph for the balloon and the mass as they fall through the water. So we are going to use the information on the graph to determine the terminus velocity of the balloon, and we're going to check the flat section of the graph, and that's going to be this part. And if we check the scale that is here, the answer is going to be 8.2 meters per second, the terminal velocity. And remember, terminal velocity is a constant velocity attained by an object when the resultant force is zero. If this balloon is moving upwards, then it means the upward force is equal to the downward force. If the balloon is moving downward, it means the upward force is equal to the downward force. So the object will be attaining now terminal velocity. Explain how the balloon reaches terminal velocity. You should use ideas about forces acting on the balloon in your answer. We are going to say that when the balloon starts moving, it experiences drag force. It experiences drag force that acts upwards, right? Now, as the speed of the balloon increases, also drag force increases. When drag is equal to the weight, it means the resultant force is going to be zero. The resultant force is going to be zero. Then the balloon reaches terminal velocity. The balloon reaches terminal velocity. So those are the key areas or the key points you are to mention in that particular question. Already we have done this question. I would like you to tell me what is the formula linking pressure, difference, height, density, and gravitational field strength. Right, pressure equals to height times density times gravitational field strength. Now, you can be able to use and calculate the pressure using that formula by substituting everything that you are having there, and that translates to 250,000. At the surface, the atmospheric pressure on the balloon is 1.0 times 10 raised power 5 pascals. Show that the total pressure on the balloon at a depth of 25 meters is 3.5 times 10 raised to power 5 pascals. So meaning we are supposed to work out, substitute the formula, and you can see now if atmospheric pressure on the balloon is at the depth of 25 meters, it means we are going to work out the pressure first, and then we shall say pressure equals to H rho G, and then add the atmospheric pressure. Already we have pressure due to the liquid column, but there is atmospheric pressure that is acting on the surface. So for you to get the total pressure at that level where the balloon is, we are going to have the sum of the two pressure, atmospheric pressure plus 250,000. We can be able to write it in standard form like that, and if you add it, you are going to get 3.5 times 10 raised power 5. Now, at the surface where the pressure is 1 times 10 raised power 5 pascals, the balloon has a volume of 0.46. Calculate the volume of the balloon at the depth of 25 meters. So we're going to say P1 V1 equals to P2 V2, because at the depth of 25 we have the pressure of 3.5 times 10 raised to power 5 pascals. Then we substitute everything that we have in this question so that we can be able to go ahead and work out the volume that is missing. Making V2 the subject of the formula, we are going to simplify this and it becomes 0.1314 meter cubic. You can see now, as pressure increases, volume also decreases. Now, the next concept that you really need to understand is about electromagnetic waves. The electromagnetic spectrum, you need to understand the similarities and differences, uses, and also hazards. Now, electromagnetic waves is a family of waves which are arranged in the order of increasing frequency or decreasing wavelength. Yeah, the similarity of these waves is that all of them, they travel at the speed of light. All of them can undergo reflection, refraction, and diffraction. All of them are transverse in nature. All of them transfer energy. Yeah, so we need also to understand the difference. The difference is based on frequency and wavelength. Never forget that. Anytime you are asked a question on differences of waves in the electromagnetic spectrum, focus on the wavelength and frequency. They define frequency and wavelength. Now, in part A, we are going to study the similarity of Wi-Fi signals. We are going to say all of them, they travel at the speed of light. Both of them travel at the speed of light in a vacuum, which is 3 times 10 raised power 8 meters per second. And the difference I've mentioned is that they have different wavelength. They have different wavelength, yeah, and frequency. State the formula linking speed, frequency, and wavelength. This is actually the wave equation. The wave equation is speed is equals to frequency times wavelength. Never forget that. This is a concept that will be asked in your exams. And then if we substitute into the second part, in order to find wavelength, we're going to say 3 times 10 raised to power 8 divided by the frequency, which is 5.2 times 10 raised to power 9 hertz. And then if we work it out, we're going to get our answer close to 0.058 meters. We transfer it here to make the examiner happy. Which of the which type of wave is Wi-Fi signal? This is a transverse wave. Describe the difference between transverse wave and longitudinal waves, and you may draw a diagram to help you answer on that. But we're going to say that in transverse waves, particles of the medium vibrate perpendicular to the direction of the wave, while in longitudinal waves, particles vibrate parallel to the direction of the wave. And then maybe you can be able to draw a diagram. This represents a transverse wave. This is a crest, and then we have here a trough, and the distance between this one, the mean position, and the highest point is the amplitude. And then we can also summarize by saying this one here is the wavelength of the wave. But for longitudinal waves, we have an object that the particles vibrate parallel to the direction of the wave. This represents a longitudinal wave. Then this is a region of high pressure. We call it compressions. Compression, let me write properly from compressions. This distance between two compressions, we have a rarefaction, region of low pressure. Region of low pressure. We have come to the end of this tutorial. Consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. See you in the next video.